Hello, this is John from caveofprogramming.com. In this tutorial, we're going to look at Lambda expressions in Java 8. So I've created a new project here and I've already got JDK 8 installed. You can see it here. And I'm using it for this particular project. You might need to download a new Eclipse to do this. So Lambda expressions are just a way of passing a block of code to a method. That's all they are. And I'm going to first go through how we would do this very briefly in previous versions of Java. And to understand this, you need to have an understanding of interfaces and of implementing anonymous classes as well. So typical situations where you might want to do this would be when you want to pass some code to a thread to execute it in its own thread. Or you want to pass some code to a button, let's say in Java Swing, so that code will be executed when the button is clicked. And if you want kind of revision on any of this, I've got a massive free Java course that includes interfaces and anonymous classes, and also a free course on multi-threading and a course on Swing, and you can find those at caveofprogramming.com. So let's start by creating a class here. I'm going to create a class, let's call it class, I'll call it runner just to give it a name. And I'm going to give this a method which I'll call public void run. Now let's imagine that for some reason we want to pass a block of code to run. So we don't want to pass integers or strings, we want to actually pass it a block of code. How would you do that in previous versions of Java? Well, the answer is first you need to define an interface. So let's do that. Let's say interface, and I'll call this executable. And we need to give this interface a method, and the method will be the place where we put the code that we want to run. Let's give it a method called void execute. Just like that. Now we can say that runner accepts an object that implements the executable interface. I'll just call it E. So it's going to get something that implements this interface, and it's going to know that that object, whatever it is, has an execute method, so it can call that method. Let's put sys out in here and say executing code block ... and let's just call e.execute. Now to actually use this, so firstly we need an instance of this runner class. Let's say runner equals new runner, and then we can call the run method. So let's say runner.run. Now in previous versions of Java, to actually pass it some block of code, we've got to somehow have an object that implements this interface, and we can do that using anonymous class syntax. In previous versions of Java, we can say here new executable, in this case, open and close curly brackets, and then let's implement the method that that interface specifies. I'll get rid of some of these lines that we don't actually need. And we can put our code in there to execute. Let's say sysout hello there. So this is all Java 6 or 7 syntax, and if we now run this program, it says hello there. So the whole point of this is just to pass in this code that to this method, and then this method can then do what it likes with it. In this case, it's just outputting something, and then it's actually executing the code that we passed it in this method. So this is a lot of text purely just to specify this. So let's have a look at how we can do that with Lambda expressions in Java 8. I'm going to just put a bit of separator text here. Let's just put in like some equal signs. By the way, Lambda expression apparently comes from mathematics, where the Greek letter lambda has been historically associated with some kind of analogous situation, passing a function to a function, something like that. So to use a Lambda expression here, we can say runner.run. So same thing again, we're calling this method. And now again, the challenge is to pass this method a block of code to execute. And we can pass this in a lot more elegantly with a Lambda expression. We need 2 empty round brackets and then an arrow. So that's just a hyphen and a right angle bracket, and then the expression that we want to run. So this bit here is the Lambda expression. I'm just going to paste this up here because I'm going to make this code available via caveofprogramming.com, so you can refer back to it if you want. And if we run this now, we can see it does the same thing as this unwieldy syntax that we had in previous versions of Java. So it's really important to keep in mind that all this is a block of code that this method is going to execute. And blocks of code, of course, they might have return values, and they might also accept parameters. And we're going to look at how we can do that with a Lambda expression. So firstly, let's ask, well, what are we going to do if we don't want just one expression like that? What about if we want multiple lines of code, a whole block of code to execute? Well, as you might guess, we can put curly brackets in here. Let's close this in curly brackets. And now, because this is a code block, now we can't just have an expression in there. We've got to have complete statements, and statements have got to end in semicolons. So let's put a semicolon in there. And just to prove the point, we can put more lines of code in there if we want to. Let's have a sysout, and this is code passed in a Lambda expression. So if we run that, again, we're executing a block of code. So the Lambda expression itself, it just passes the code, and then it just so happens in this case that the method I'm passing it to, run, happens to execute it. But of course, it could do whatever it liked with it. So the Lambda expressions they're always associated with interfaces that have a single method. Java 8, as far as I know anyway, it doesn't introduce any new syntax for specifying in your method parameter that it's expecting a block of code. You still have to use interfaces, just like you did in previous versions of Java. The thing that's new is we've got a simplified syntax for passing in that actual block of code. And Java 8 also introduces some new terminology. In Java 8, if we've got an interface that just has a single method in it, like this one here, then we call that a functional interface. So a functional interface is an interface that just has one single method, like this. And an example of that would be the comparable interface or the runnable interface in Java, but we've just rolled our own here. We defined our own version of a functional interface. Let's copy this, and I'm going to paste it up here as another example of a Lambda expression. If you're anything like me, you'll sort of probably get gradually lost as you're going through this tutorial, but as long as you understand already anonymous classes and implementing them, and you understand interfaces, it's only a question of typing this out a bit yourself to get it into your head, because it's not really complicated. It's just that, as with programming in general, you've got to type it. You've got to type your own examples and get them to work in order to get it into your head. Just looking at it, it gets a bit confusing. So what about if we want a return value from the block of code that we want to execute? So in previous versions of Java, what we have to do is, well, and also in Java 8, the interface has to change. So often you'll just be using Lambda expressions. You'll just need to remember this kind of stuff. But in this tutorial, we're also looking at defining code that uses the Lambda expression. But most often you'll just be creating a button or a thread, and you only need to know how to define the Lambda expression. You're not going to need to create the actual method that uses it, but we'll do that anyway. So if we want the code that we pass to our method, if it expects that code to have a return value, first we need to modify the interface. Let's modify this interface here. so that it returns an integer. We do something in the method that block of code is passed to. So here, where we say e.execute, we could say int value equals, and then this out here, for example, and say return value is, and let's just output the value there as well. So in old versions of Java, now we'd have to use anonymous class syntax, or we'd have to implement this interface somehow, create an object and pass that object to the method, and this anonymous class syntax previously is the quickest way of doing that. So here our anonymous class now, of course, its execute method has to change. Now it's got a return type, and it can then return it with a return statement. It can return some value, let's say return 7. With the Lambda expression, we can also just put in the return value, let's say return 8. So we don't need to specify the return type anywhere. There's nowhere to do that. All we've got to do is just literally return something, and Java knows what the return type is going to be anyway, because it knows what the interface looks like, and the interface specifies the parameter to the method that you're passing your block of code to. So we just need this return value here. Let's run this, and it says here return value is 8 from this code here. So that's another example of a Lambda expression. Let's copy that, and I'm also going to paste it at the top of the program here. Now sometimes all you've got here is either a literal value, or more likely a method call that returns a value. So here, if we look up here, the first Lambda expression we saw was just an expression, which was actually a method call, println. And in this case, Java would actually not only run this expression, but it would also get a return value from it. So if you've just got a single expression, which could even be a literal value, you don't need even a return statement. So here, if we didn't need this code here, we just needed this. So one way of doing it is just get rid of this, and we can have a block of code that says return 8. So again, that's a valid Lambda expression. Let's add this to the menagerie up here. So let's put the multi-line comments in, paste it in. But you don't need these brackets if it's just a single expression. So a valid single expression would just be 8, like that. So this is a perfectly acceptable Lambda expression, where all it's doing is saying return 8. That all this block of code does is return a value 8. And this could be a method call. It doesn't have to be a literal value. More likely it is going to be a method call. So let's run this. As long as it's a single expression, you don't need the curly brackets, and it says return value is 8. So again, let's bung this in up here. Another thing that you often want to do is the block of code that you pass to your method will often have parameters. So remember, we don't want to pass in literal values with our block of code. We're passing a block of code, and the method that you pass it to will then supply the parameters to the block of code, if there are any. So let's say this interface, let's say it has execute has a parameter, and again, just for simplicity, I'll just make it an integer. It could be anything, it could be an object, it could be a class, whatever. So let's say here int, and I'll just call it a, because I don't know what it is. So let's just say a. And now the actual method that you pass that block of code to is going to have to supply a value for that parameter. So let's put in here, well, let's put in 12, like that, just randomly, Okay, so we're passing in value there. And our block of code down here, so in the old kind of anonymous class syntax, again, we've got to modify this execute method because, as we saw up here, it's now got a parameter type int. So let's say in here, int a, I could give it a different name, but for consistency, let's call it a again. And our block of code that we're passing could do something with that. Let's say it could return 7 plus a, for example. Now in the Lambda expression here, down here, it's really simple. We just put the parameter here between round brackets. So remember, it's a block of code. It could have parameters and it could have return values. So it's not going to be a literal value that we put here. We're just specifying what parameters this block of code that we're passing to a method actually expects. So let's say here, int a. I'll call it a again. I could call it anything, but I'll call it a. So again, this works just as before. Again, we've got a valid Lambda expression here, and if we run this, it's going to say executing code block. So yeah, let's copy this. Let's paste it in up here. So it's another Lambda expression. Whoops, not that. But this is a valid Lambda expression. And if we want it to be more similar to this, yeah, of course we could put the curly brackets back in, because probably most often you'll want those curly brackets because it's a bit useless, usually, just having a literal value in there. But often it will be just a method call, though, for that matter. Just format that. So here we've got the same thing as this. It's just instead of going through all this rigmarole, we've defined it a bit more succinctly. So let's just run this and check that it works. And we've got the same thing as this here. So again, another valid Lambda expression, which I shall paste into my Lambda expression zoo up here. There we go. Now often you can miss out this the type of the parameters. You can have multiple parameters, and often you don't need to specify the type. Let's just delete that. So we're just saying a, we're just giving it a name. That's all we're doing. We just have to give it a name because we might want to use it in our block of code. Most likely you will. And so we're using the name here. Let's run that. That also works just fine. Java can infer the types of the parameters that you list here. You can have a comma separated list of values. It can infer them because it knows what the interface looks like here, and it knows what this method expects. So yeah, let's also bung in this up here. But sometimes you do need to specify the type of the parameters. Let's take an example of that. So here, runner, it just has one method run, which expects this interface executable. Let's create a whole new interface here. Let's say we've got another interface. I'm just going to call it string executable, just to make up a name. And I'm going to give it a parameter of type string, which I'll leave it at a, because it doesn't really matter what we call it. And let's give this runner another method. And this method actually accepts string executable, and it passes in a string there. So now we get an error down here. Why? Because we're calling runner.run and we're giving it this Lambda expression, but Java doesn't know whether we mean this method, which expects a interface that has a method that takes an int, or this method which expects an interface that has a method that expects a string. It doesn't know which one of these we mean anymore. It's become ambiguous. If we look here, we've got an error that says the method run is ambiguous for the type runner. So in that case, we do need to specify what we mean here. So we could make this a string, but then of course, well, it might work with a string. I'm not sure. Let's try that. And no, that's not going to work because we've got to return an int. Let's put int there. When we put int in here, now Java knows that we mean this method here, because this interface is the one that has the method that expects an int. So in this case, we had to specify the type of our parameter because it needed to disambiguate between those two possible run methods. But most often, you can just miss out the types of the parameters there. And in fact, if you've only got one parameter, then you don't need these brackets. In fact, I think if we delete these, this isn't going to work because we've got that int in there. But supposing we didn't, let's comment out this for a second. Get rid of the ambiguity. So because there's not going to be any ambiguity, then we don't need to specify the type of the parameter. And now we can use this syntax where we've just got the parameter by itself. So this again is a valid Lambda expression. We've only got one parameter, so we don't need the curly brackets around it. And the parameter has no type. If it did, again, we'd need the round brackets around it. But if it's just one parameter, single parameter with no type, you don't need those round brackets there. So again, we've got a valid Lambda expression, which I'm going to paste up here. So what if you have multiple parameters? Well, of course you can. It's pretty simple. Let's say here we've got int A, int B. Let's modify the method that we're passing the code to supply those values. Let's say 12, 13. And now for the anonymous class, we've got to put the other parameter in, and we can make it like add the two together. Let's say A plus B. For the Lambda expression, we're going to have to put the brackets in again because we can't type A comma B, unfortunately. But we can just type it like that with round brackets around it. In fact, in this case, now even if I uncomment this method, there's no ambiguity because one of these methods in the interfaces takes two parameters and the other takes one. So we don't need to specify the types anymore. It's not ambiguous. So let's run that and check that it works. So again, we've got a valid Lambda expression there. And I think that's all of the different Lambda expression variants that I can think of to show you just there. So it looks complicated, but it's not really. It's quite simple. And when you worked with it for a little while, you typed out some examples, you realize that it's just not that complicated at all. When you use it, it's really quite simple. And if you want to define a method that expects a Lambda expression, then you need to understand anonymous classes and functional interfaces. So remember, this is called a functional interface in JDK8 because it's an interface with just one method. One extra little thing is, what would you do if you want to use variables from your calling method in your block of code down here? Well, you can do that. So let's say we've got here let's just make it int again. It's the simplest thing. Let's call it int, I don't know, C equals 100. Now, in the anonymous class syntax here, we can use C, but we can't just use it as it is at the moment. If we type that, save this, well, it turns out we can. In JDK 7, if you used a local variable in an anonymous class, you had to declare it final. But in JDK 8, and I realized this was true for Lambda expressions, didn't know it was true for anonymous classes, that final is no longer necessary. So we can use our int C in here. But the thing is, this doesn't work if we change the value of it later on. So we've got like some new terminology, more terminology here, which is if you declare a variable and you assign it a value immediately and you don't change it, so mustn't do this. Then we say this is effectively final because we declared it, we gave it a value, we didn't change it. So it's not final, but we say it's effectively final, and we're allowed to use effectively final variables now in our methods of anonymous classes, and we can also use them in Lambda expressions. So let's change this to A plus B plus C. So I'll write this the same way around up here as well, just to keep it the same. So we can happily use local variables within our Lambda expression as long as they are effectively final, or for that matter, actually final. There's the Lambda expression, it doesn't have its own scope. So in anonymous classes like this, let's say we had a int d, like that. I'll give it a value as well, actually, it doesn't really matter. Down here we could say int d equals 8. So what is this? It's a completely new variable that shadows this. So once we've done that, we can't access this anymore in here. We've just declared a new variable entirely. So can do this in methods of anonymous classes because they have their own scope. Here, this has its own scope, but this is not a new scope as such in a Lambda expression. So here we can't type int d equals something. So if I save that, it's not going to let us do that because it's actually working with the scope of the method that we define it in. So the error message here is Lambda expression's local variable d cannot redeclare another local variable defined in an enclosing scope. So I'm not sure technically if you call this, I guess it's not a new scope, but anyway, whatever you call it technically, the fact is that there's you can't just define a new variable in here that you've already got here. It's not a new scope in the same way that it was with a method of an anonymous class. Let's say can't do this. No new scope. So that's it for this tutorial. This took me a little while to get my head around, but once you realise that it's purely a new way of doing methods of anonymous classes, it works differently under the hood, but from a programmer's point of view, it's just a little bit of a new way of doing the same thing that's a bit shorter. Then it's a lot simpler, and you have to keep in mind that you are passing a block of code, and that block of code may have parameters, it may have return types, and that's really all there is to it. So yeah, just I'd recommend practicing that a bit if you're new to it, and you should get the hang of it pretty quickly. There's been a certain amount of excitement around Lambda expressions because people are saying this opens the door to functional programming where you're passing around functions, because the Lambda expression is actually an object. Yeah, I've just remembered a couple more little things that I want to show you. To me, it's not that exciting because after all, we could do this in a previous version of Java. It's just that we had to use a more unwieldy syntax, and we still don't have a way of specifying in a method. We don't have a more succinct way of specifying that this method expects a block of code. We've still got to work with interfaces, as far as I know. So it's not exactly a radical overhaul. It's almost like syntactic sugar, although it isn't. It works, it's implemented differently to this apparently, but I'm not so excited about it myself. What is nice is that if you're passing some code to a thread or a button or something, you can now do it without typing all this rubbish out, which is clearly overkill for just passing a bit of code. So because the Lambda expression is an object, you can assign it to whatever functional interface you're working with. Let's take this as an example. Let's just copy it. We can say, what's our interface called? It's called executable here that we defined. So you could do this with runnable or comparable or whatever. We can say executable x equals, and paste in the Lambda expression here, and that will work fine. And you could pass that to runner.run x like that. That would work. If you want to assign it to an object, or you want to assign it to some superclass of this interface, then you might need a cast in there. So it is legal to do something like this. Let's say object, let's call it code block equals this. We can do that, but we need to put a cast in to executable like that. We need to put that cast in there to make that work. And after that, it works. So yeah, another really good use of this is, of course, to implement the comparable interface. And as far as I recall, in previous versions of Java, array lists didn't have a sort method. I don't think they did, but now they do. They have a sort method that you can pass something that implements comparable to say how the list should be sorted. And the Lambda expression is a really good use of that. You can do it very succinctly. You can implement the sorting algorithm in a Lambda expression, and you can use your array list and say .sort and pass it the expression. But I won't give you an example of that because this tutorial is already very, very long. So that's it for this tutorial. There's a lot of free tutorials on my site, caveofprogramming.com, as well as some premium paid ones. So I hope you'll check that out. And until next time, happy coding.